Hello everyone. This presentation aims to subjectively evaluate our proposed feature-based collaborative filtering style explanation that exploits multiple data sources as compared to conventional collaborative filtering and content-based style explanations that mostly rely on single source of data. So let's get started. There are many existing approaches to generate explainable recommendations. For example, in case of collaborative filtering approach, which only requires availability of explicit or implicit feedback from users, and then try to predict the ratings for the items to recommend. And many attempts have already been made to explain these predictions to users, but is still a challenging task. Common examples of such explanations are the Amazon customers who bought this also bought explanations describing why an item has been recommended, but in a rather simple manner, independent of the complexity of the underlying model. On the other hand, content-based rely on, for example, predefined metadata or tags generated by users or extracted from unstructured text to provide explanations. But this approach requires availability of content data, which is not always directly available. Examples of such explanations can be seen in Textplanation and NewsTude systems. Both collaborative filtering and content-based style explanations, they can be considered effective in most standard recommendation scenarios, but in reality, recommendation process is much more complex, especially in high-risk domains, for example, digital cameras. In such cases, the user's decision becomes more difficult, where deciding to buy a camera is much complex than choosing a movie to watch. So in such cases, being able to fall back on multiple data sources could generate more transparent and argumentative explanations that could actually help users in their decision process. Hybrid approaches exist that have already combined collaborative filtering and content-based data, but these approaches mostly focus on improving the system accuracy rather than generating explainable recommendations. And even in cases where the explanations are provided, they do not explain how the recommended items are relevant to the current user in terms of their shared preferences for item features. In this line of work, we in the previous work proposed an approach that basically combines content-based with collaborative filtering in a hybrid manner, but with the purpose of providing explainable recommendations in terms of exploiting content features. So how our approach works. In the first step, the user item ratings metrics and the item features metrics are exploited in an entropy-based feature weighting technique that basically computes feature weightings for each user. This creates feature-based profiles of all available users in our data set, and this is the process which is done offline. In the cold start, we elicit the active user's preferences with respect to features of cameras by explicitly asking the user to rate number of features. In the next step, the active users as well as the other users' feature-based profiles are exploited in a cover similarity approach to compute users who are actually similar to the active user in terms of their shared feature-based preferences. The system then generates item and feature recommendations as well as their corresponding explanations based on these similar users' preferences. The idea of our approach is to explain the recommender's output via item features, yet an in-depth empirical evaluation of our proposed approach is missing from user perspective, which we basically aim to address in this current work. We then implemented a prototype system on top of this approach, which provides different levels of explanations, which I will just briefly explain here. As the recommendations are generated from similar users' feature-based preferences, therefore, we first explained how these users are similar to the current user in terms of their shared feature preferences. Then we explained each recommended item based on similar users and the active users' feature preferences and how this item matched those preferences. Our approach not only recommended items, but also features of the items, where each recommended feature is further explained in terms of how similar users have selected this feature along with the specific feature value. So in this work, to subjectively evaluate our proposed approach as compared to established baselines, that is item-based collaborative filtering and content-based, we formulated following hypothesis. That is, feature-based collaborative filtering improves subjective assessment and user experience as compared to recommendations and explanations generated by item-based collaborative filtering and conventional content-based approach. So to test our hypothesis, we conducted basically 2 user studies. The first user study was conducted in a within subject design to test our hypothesis one, where each participant was presented with both feature-based collaborative filtering system and item-based collaborative filtering system. And the second user study was conducted in a between subject design to test our hypothesis two, where each participant was presented with either feature-based collaborative filtering or content-based system. In both user studies, we first explicitly elicited users' preferences in terms of either items in case of collaborative filtering or in terms of features in case of our approach or in case of content-based approach. Additionally, in case of our approach, they were also required to rate the selected features. Then the system generates corresponding explanations and its explanations, recommendations and its explanations. Participants were required to explore the system and its functionalities, then select a camera that matches their preferences, and then subjectively evaluate the system by answering series of questions. The questionnaire items were taken from existing recommender evaluation frameworks. Additionally, we used self-created items for decision support inspired from existing work. System usability scale and user experience questionnaires were used for overall user experience evaluation. In the first user study, 20 university students participated. In this study, we compared our feature-based collaborative filtering approach with item-based collaborative filtering, and all participants experienced both systems in a counterbalanced manner. In the item-based collaborative filtering system, as you can see in the figure, the explanations were provided in relation to the user's previously rated items. To test the first part of our first hypothesis, that is, that our approach improves subjective assessment of recommendations and explanations when compared to conventional item-based collaborative filtering, we conducted one-way repeated Myers-Manova and found statistically significant differences between two systems for aggregated dependent variables. Univariate test results further revealed that our approach significantly performed better in terms of perceived recommendation quality, explanation quality, transparency, satisfaction, and decision support. Yet results overall indicate that we can generally accept hypothesis 1. Then we tested second part of our hypothesis 1, that is that our approach improves user experience compared to conventional item-based collaborative filtering approach, but found no significant differences in terms of interface adequacy and system usability scale. However, our feature-based collaborative filtering showed slightly better results. In general, we cannot accept this hypothesis. However, in our qualitative feedback, majority of participants preferred our system. The second user study was conducted to test our second hypothesis, where we compared our feature-based collaborative filtering approach with content-based approach, but in a between subject design. We recruited 100 Amazon Mechanical Turkers and used the data of 73 after excluding outliers. In content-based system, as you can see in the figure, the recommendations and explanations were generated by simply matching the user selected features with the item features. To test first part of our second hypothesis, that is the feature-based collaborative filtering improves subjective assessment of recommendations and explanations compared to conventional content-based. We again conducted a one-way repeated Myers-Manova and found statistically significant differences between two systems for aggregated dependent variables. However, the differences were only significant in terms of two factors, that is decision support and overall satisfaction, where content-based performed better than our approach. Yet results overall indicate that we cannot accept this hypothesis. Then we tested second part of our hypothesis, that is that our approach improves user experience compared to conventional content-based, but found no statistical significant differences in terms of interface adequacy and system usability scale, and also in terms of user experience questionnaire this time. Overall, this hypothesis can also not be accepted. So basically, to summarize our results, our approach performs significantly better than the item-based collaborative filtering. However, in second user study, the content-based performs significantly better. But in case of both user studies, there were no significant differences between systems in terms of user experience. The reason that why content-based condition was positively perceived by participants might be explained under the assumption that participants were still provided with everything needed in terms of content features, and that might be sufficient for them to make their decision. The insignificant differences in user experience can further be explained in terms of the qualitative feedback that we collected. When we asked participants about why they like and disliked about our system, even though many liked the amount of information, explanation, as well as the ability to rate features, but for many of them, the information was quite a lot and a bit overwhelming. For some, it was also confusing to figure out how to use the system, and they also suggested to simplify the system a bit more. And this might explain why our approach did not perform significantly better in terms of user experience as compared to item-based collaborative filtering and content-based approach. So to conclude our work, the gain through the integration of additional content features with collaborative filtering approach becomes more prominent when compared with item-based collaborative filtering that does not take features into account. But it becomes less prominent when compared with content-based approach that already exploits content data. The insignificant differences in user experience might be explained in terms of complex interface design, as indicated by participants in their qualitative feedback. On the other hand, this might also indicate that when our system compared with either item-based collaborative filtering or content-based approach, participants perceive the systems of equal quality, which still draws a promising picture for our approach. And our future work would focus on further investigating and addressing those concerns of the participants. So thank you for watching this presentation. Bye.